If you're new to synthesis and modular systems, you might be wondering what's this CV, VC, VCO, VCA voltage thing. What is voltage? All right, so voltage is basically one component of electricity. And you could consider it as the amplitude, and it's actually the compression of electrons within the copper wire, but whatever. You can see it here. It's just an amplitude, basically. It's a signal, right? So this is one amplitude, this is one amplitude, this is one amplitude. And we use something called voltage to send the different amplitudes. So basically this is another parameter, and if we move it, we see it starts to get plotted over time. So we have VCA, which is a voltage controlled amplifier. And why do we call it that? It's because we can control the amplitude with voltage, right? This is sending out this voltage signal. So if we map this here, now this is a VCA. It's a voltage controlled amplifier. It's an amplifier. This volume thing, it's controlling the amplitude of the sound, and we are controlling it with voltage, making it a voltage controlled amplifier, VCA, basically. So in a module, you have different inputs and outputs for audio and control voltage signals, and you can also use audio as control voltage signals because audio is also voltages. So this is a basic techno loop from my modular, and this is it's just one signal, right? It's one voltage signal that is vibrating like this. You see, if we zoom out, the less details we see and the more familiar it starts to look. Now it looks like a SoundCloud track, right? And then we zoom in, it looks like this. And this is what sound looks like. It's compression of electrons. So here it's more compressed, it's higher amplitude, less compressed, lower amplitude. And we could actually send this to a parameter so that it starts to wiggle the amplitude, let's say, of an amplifier or the pitch of an oscillator in audio rate, and it starts to wiggle it like this very, very fast. Or of course we can do it slowly with an LFO like the spellbook, and it looks like this. And then the faster and faster we start to go, and eventually you can't see it here, and it starts to go into audio rate, right? And you can do all sort of weird stuff. And basically this is now I'm sending CV. No, yeah, well, I'm sending control voltage to this one. I'm sending a kind of digitalized representation of CV here. So basically this is the building block of synthesis, and this is the art of synthesis. Basically it's how you combine voltages into sound, because sound is voltage. It's very rapidly oscillating voltage, and then we're using different types of voltage to control these oscillations, right? So if you have an oscillator that creates a sine wave, we could use another sine wave to temporarily make it go faster, so it goes up in pitch. It's called frequency modulation. And then we can use different shapes to frequency modulate it, which starts to crack kind of the shape. And as we get these kind of cracks in the sound, we get overtones, and then we can use a filter, which we can control with voltages to shave off the overtones sometimes and show them sometimes. It's called a filter sweep. And it's used, it's like the building block of subtractive synthesis. The field of synthesis is like science. I would say it is science, which is so great and a lot of fun and creative, of course. So I hope that gave you an idea of what voltage is, and we can go into more depth about each of these topics, like what is sound, what is actually voltage, and Ohm's law and all of that. But that's beyond the scope of this video. Now I just wanted you to go explore.